Hi, this is lesson 19 in the use of JASP. And today we're going to continue on with exploratory factor analysis. I want to go over and open from our database or data library. Let's go and find number 6, factor for factor analysis. And let us go with the file on mental ability. I'm going to open this up, and there's a description for confirmatory factor analysis. We'll come back to that. We're going to start with exploratory factor analysis, but let's first take a look at what this data set contains. Most importantly, I want to focus on factor analyzing these variables called x1 down to x9. You'll notice that the first three of these, x1 is visual perception, then cubes, then lozenges. I don't think that's talking about throat lozenges. These are measures of visual perception. Then you have our spatial ability, would be a good way of framing that. Then you have vocabulary. X4 is paragraph comprehension, then sentence completion, word meaning. Vocabulary is well known to be a major indicator of intelligence. This is all about mental ability or IQ. And then we have 7, 8, and 9 are all speeded tasks. How fast can you do something, which gets at, how efficient the mind is in working to do computation. So speeded addition, speeded counting of dots, speeded discrimination of straight and curved capitals. And so that would be capital letters, right? So we want to see, I've already laid out that it should be the case that these lay out as three constructs or three overarching concepts that the measures get at. And so we're going to do a factor analysis on these. We're going to do an exploratory factor analysis. So I'm going to go to factor. I'm going to go to exploratory factor analysis. And I'm going to put in my 9 variables. And it goes ahead and it automatically does an exploratory factor analysis. Now the question is what kind of factor analysis did it do? That's based upon what is already set up here. So if we go and first look at the number of factors, it based this on a parallel analysis, which we talked about in the last video. The more common way that like SPSS does and traditional programs do, but it's not the gold standard, is eigenvalues. If I go ahead and do eigenvalues over 1, nothing changes. That method also comes in with 3. You can do manual and say 1. It really doesn't like that. It's come up with 4 items loading on one factor, and then the rest of the items don't load well, so that really didn't work. So I can manually go ahead and specify 2. That works a little bit better. 3. And now I'm back to the same solution that I got using the eigenvalues or the parallel analysis. Okay. More about that later. We also did an oblique rotation with a that there's multiple types of oblique rotations, and the ones that are most typically used is Obleman is the first one that comes up in SPSS, although Promax is also there. GeoMin is one that M+ uses. There's a number of these here, but Promax is probably the most commonly used. And then we have output options. So for output options, it's showing display loadings above 0.4. Some people like to go down to 0.32. It's not going, well, there is a 0.344 there. So that's not quite as pretty as if you select 0.37. So you notice that the further down you go, the more loadings show up. If I go all the way to 0, you see all the loadings, but you see that some of the loadings are really, really small. And really small loadings don't count much, so there's no reason to take a look at it. So to give you a better view of the factor structure, it's better to make the loading something like 0.32 or 0.40. And now it's looking very pretty. I actually have it at 0.35. There's also something called a structure matrix. I'll try and come back to that. And factor correlations. So I wanted to show the factor correlations because if you do a oblique rotation, that means you're allowing these factors to be correlated. So you really don't understand exactly how the factors are working to reproduce the correlation matrix, and that is the goal. How well do we reproduce the correlation matrix? Unless you also understand the correlations between the factors. And this is saying that factor 1 is correlated 0.257 with factor 2, it's correlated 0.391 with factor 3, and factor 2 and 3 are correlated at 0.350. Let's take a look at let's do our scree plot with the parallel analysis results. So a scree plot is used to give you an idea of how many factors there are. And the parallel analysis has become the gold standard. What it does is it gives you a how much of the variance do you expect the items to have in common if they were functioning basically on a random basis. Even on a random basis, you'd expect them to enough items to still share some things in common. And so you have, based upon your sample size and the number of items that you have, it is giving you an idea of what you expect randomly, and this is comparison with the eigenvalue rule. So you notice that eigenvalues of 1 would be here. And here's what we actually got in terms of how the variables, how well they clustered together in terms of having things in common, which is given mathematically by indices that are called communalities. So you have these mathematical operations capturing the communalities, and there's a lot in common by a single factor. And then there's a second one that's still capturing communalities, and then a third one. And then by the time you get to the fourth one, it no longer is accounting for enough in common that it's even giving you an eigenvalue of 1. An eigenvalue is a measure of those communalities, how much force a certain factor is going to have in accounting for variance. So you could think of it as the power of a vector. So the eigenvalue can be thought of as the power of an eigenvector. And those vectors are capturing the different factors. And you'll notice that there's 3 of these that come out above what is expected on random, leading us to conclude that there's 3 factors that we should keep. This is consistent with the eigenvalue rule because by the time we get to the 4th, it is not meeting the standard in terms of the parallel analysis, which would mean that that dot would need to be above the triangle spot over here. It's also not meeting the eigenvalue rule. So either way you go, you get 3 factors. Okay, so to understand how this analysis works, what I want to do is to go back to the underlying correlational structure, because this analysis is all about reproducing the correlational structure. To do that, I'm going to go to regression, just so I can go underneath regression to correlation. And I'm going to take those 9 variables in our data set and stick them over here. And I wanted them to display them as a matrix. There we go. So now we have the correlation matrix, the correlations between all 9 of the items. So our visual ability, our test of cubes, our test of lozenges or diamond rhombus shapes. These get at, how the items are manipulated and so forth. Then the verbal ability, and then the speeded cognitive task. I want to take a look at this over in, I borrowed from this and put it over into a PowerPoint presentation. What I want to do is to show you how this matrix divvies up to assess 3 constructs. That is, you can think of these as traits: verbal, spatial ability, the visual shapes, probably we should call it spatial ability, verbal ability, and speeded task. Let's take a look first at the upper triangles. These clusters of variables within each one of the traits. So here I have multiple measures measuring spatial ability. And I notice that they tend to correlate significantly. They correlate between, a moderate correlation would be about 0.3. A strong correlation is around 0.5. So they're moderate to strong. For verbal ability, the correlations are very strong in the 0.7 range. This is exceedingly good and gives us what we would call convergent validity. That is, they're converging or clustering, being highly correlated to say these are all measuring the same construct, the same idea. And then down over here, we have again, medium to strongish correlations measuring our speeded task. All these correlations are significant and they're all medium to strong. So the first thing that a factor analysis is getting at is how the items cluster together. And the clustering is based upon the measures converging. So we call those convergent validity, right? How the measures converge to get at the assessment of a more general construct. Now, if they do this well, there should also be divergent validity. That is, the measures of spatial ability should not correlate that well with language abilities. And you notice that when you look at these, there's some of these that are not significant. 0.182 is not significant. A lot of these are significant still. But you'll notice that some of the correlations are pretty small. None of them are very strong. Most of them are lower than the correlations over here, though it's not perfect, especially over here with these correlations tend to be a bit high, posing a tiny bit of concern there. But these correlations are way less than these over here, which is really good. Now, probably the best way to do this is to look at the averages. So the average correlations in this triangle is 0.359. The average correlation in this triangle is 0.72. The average correlation in this triangle, 0.426. So we have average correlations in the triangles that run along the diagonal, telling us about convergent validity that are between medium correlations to strong correlations. In this case, with the vocabulary, very strong. These convergent validity averages are substantially stronger than the divergent validity coefficient. So the average for all the correlations in this box, 0.216. The average over here is getting close to small, 0.166. And this one is pretty small as well, 0.16. So this is excellent evidence of a combination of convergent and divergent validity, which leads you to expect that you should have 3 clusters of items. Let's go back to our exploratory factor analysis. That's exactly what we got, right? You'll notice that the vocabulary, which had the strongest correlations, also have a very strong factor here with coefficients or what are called factor loadings of 0.80 to 0.89. These essentially represent the correlation of the items with the factors. Okay, correlations of the items with the factors. And 7, 8, and 9 were speeded tasks. That factor is also coming out fairly nicely. And then for the spatial ability, you have a third factor. So it's showing you how the items cluster together to represent these 3 constructs, with each factor being an overarching construct. And that is essentially how this exploratory factor analysis works. So that's it for today. Stay tuned for more lessons. Bye.